This is the tutorial video of a linear first-order equations in which it has a linear form, an important class of differential equations which can always be routinely solved by the use of an integrating factor. So by its definition, first-order differential equation cannot contain products, powers, or other nonlinear combinations of y or y prime. So the linear first-order equations has its standard formula, which is dy over dx plus p of x y equals f of x. So cite an example. We have a problem x minus y dx plus x dy equals 0. So from this equation, we must transform it into its standard form. So the x dy here should be transposed to the left side. So it becomes x minus y dx equals negative x dy. And then the dx, we should undergo cross multiplication so that the dx here is on the denominator of dy, and then the negative x here should in the denominator of x minus y. So now it becomes negative x minus y over x equals dy over dx. And now it will be transformed into its standard form, which is dy over dx plus negative 1 over x y equals negative 1. So here is now our standard form. And then the next step is to find its integrating factor, wherein the integrating factor is v equals e to the integral of p of x dx. So our p of x here is negative 1 over x. So let's substitute. So the integrating factor v is equal to a to the negative dx over x. So the answer is 1 over x. So the integrating factor is 1 over x should be multiplied to its standard form. It's multiplied by the integrating factor. So the result is now y times the integrating factor equals the integrals of negative x to the negative 1 dx. Now y times 1 over x equals the integral of negative x to the negative 1 is the negative ln of x plus ln of c. And then it now becomes y times 1 over x equals, from Math 61, now becomes ln of c over x. And then the value of now the value of y is now y is equals x ln of c over x. Here is now our answer to find the linear first order equations.